Okay, there's a couple of things that I've already noticed on this video that I'd like to go through and do a quick review on with you on before we get to going too far. The first one is, let me just use this drawing. Let's just say we have three populations, this one and this one and this one. And then the mean of this one is here, and this one's mean is here, and this one's mean is here. And so, since this mean is so far away from these others, you'd expect the variance between the means to be greater than the variance of all these values. You know, obviously, if we were to go through and, you know, all of these three populations have got something like that, where the means are right there close together, you wouldn't expect any difference between the groups. But in this situation here, where this mean is significantly different from those others, then you would expect some sort of a difference. And then the other thing that I wanted to point out was on these values here, this degrees of freedom was the number of groups, which was 3 minus 1. And this, the factor, can also sometimes be called the between groups. The error can sometimes be called the treatment. I'm sorry. Read my own notes. The factor can sometimes be called the tween groups or the treatment, and then the error can sometimes be called the within groups. Then SS was the sum of squares and MS was the mean square. So those were the points that I wanted to make at that point. Let's rejoin the video at this time.
So the F value is the variance between the samples divided by the variance within the samples. Sometimes that's said the variance due to the treatment between samples is treatment, and variance due to error is within the samples. Large F values result in small P values. The greater that ratio, the smaller the P value. Okay, now let's talk a little bit about two-way analysis of variance. One way, you have one factor, one variable. You have different treatments. You know, one. And then two-way, you have two variables or two factors, such as gender and age group. You could have a group between 10 and 20, 21 and 30, 31 and 40. Three groups there, then male and female, and you want to see if they differ on test scores or in how fast they run the 100-yard dash or something like that. For you guys, we could do a fuel use to see what the miles per gallon, how that changes based on whether we have 4, 6, or 8 cylinders in an engine, and whether the transmission is automatic or manual, and see if that has if that changes by the fuel use. We could look at the location of a house, where it's on the ocean front or whether it's in the middle of town, and the number of bathrooms, whether it's 1, 2, 4, whatever, and the selling price, to see if there's some differences there. Those are just some examples of two-way analysis of variance. Two-way analysis of variance does add an interaction factor. And if the interaction is considered to be significant, then both factors must be considered when looking at the result. This is in your textbook. This is analysis of variance. This is a test to see if the interaction between the two factors, use the mean square interaction over the mean square error. It's calculated just like we did the earlier ones. If there's an interaction due to an effect due to the interaction, then you stop. You have to consider the effects of both factors. So this gets it close to thinking about something that's similar to the correlation, although these factors do not have to be interval, but you can think of it maybe in that way a little bit. If there is no interaction factor, then you can continue. But if there is, you have to stop. If there is no interaction factor, then you can see whether it's the row factor or the column factor that is causing the difference. So why don't we do multiple one-way ANOVAs instead of a two-way ANOVA? If we do two one-way ANOVAs, then we lose. Well, I misspelled lose. Sorry about that. We lose the test of interaction, and that test is an important test. And also it changes the level of the confidence. We talked earlier about using multiple t-tests instead of a single ANOVA. The same thing would happen if we use multiple one-way analysis of variance instead of a two-way analysis of variance. It changes the level of confidence. And we might as well learn that there are three-way ANOVAs and four-way ANOVAs. They're beyond the scope of this textbook, but they're out there. So if you wanted to do gender and age and hair color or something like that, then you could see if there's a difference in the groups. So let's look at a demo. Give you a little bit of an idea how this works. I've been real pleased with how this has worked. So here we go. There's four groups here, and this is the variance.
Before we get to that demo, I don't think we're going to be able to finish that up within the time limits of this particular one. I do want to take care of that. On the textbook, I do, just to clarify, make sure, we do have on the terms to define the between. This would be the treatment or the factor, and then within could also be called the error. So we'll stop here and come back